Good morning. Okay, last class we discussed about what is discrete Fourier series, what is discrete Fourier transform, properties of discrete Fourier series. Okay, and some problems also we have done in our last class. So, hmm, so many problems are there. Now we'll see some of the problems. So see here, and we have also discussed about the frequency spectrum and the phase spectrum of the DFT also. Okay, so this is the frequency spectrum and phase spectrum. Okay, so let's see the another problem, that is determine the 8-point DFT of the sequence x of n equal to 1 1 1 1 1 1 0 0. Okay, this is the given sequence. We have to find out the 8 point. Here we have 8 elements. 8 points are there. 1, 2, 3, 4, 5, 6, 7, 8 elements. 8 points are there. That's why it is the 8-point DFT. So we have to find out that is Fourier transform to given sequence x of n is this sequence. So what is the formula for finding the DFT x of k equal to sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n, where k is 0, 1, 2, 3 up to n minus 1. Or how much will be the n? N is 8. So n minus 1 is 7. So this will become x of k equal to sigma n equal to 0 to 7 x of n into e power minus j 2 pi n. K value is k by n value is 8. So n k by 8. So it will become n j pi n k by 4. Okay, by substituting the values of k equal to 0 to 7. 0 to 7, we will get different values. 0 to 7. Okay, so we substitute these values. If k is 0, then it will become x of 0 equal to sigma x of 0 e power 0 by e power 0, that is 1, plus x of 1 into e power 1. Here k value is 0. It is also 0. So for all e powers will become 0. So that it will become x of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4 plus x of 5 plus x of 6 plus x of 7. So okay, here x of 5 and x of 6 are 0 and 0. So these values are all ones. 1 plus 1 plus 1 plus 1 plus 1 plus 1. Okay, so it will become 6. Okay, so x of 0 value is 6. Similarly, if k equal to 1, then x of 1 will become x of 0 and e power 0 plus x of 1 and e power minus j by n into k value is 1 by 4. Okay, n value is here n value is 1. Okay, like that we will substitute these values. X of 2 e power minus j n is 2, k is also 1. Okay, by 4. Okay, so that it will become x of 0 plus x of 1 e power minus j pi by 4 plus x of 2 into e power minus j pi by 2 plus x of 3 into e power minus j 3 pi by 3 pi into pi by 4. Okay, 3 pi by 4 plus x of 4 into e power j pi and j pi plus x of 5 into e power minus j pi pi by 4 plus these two are zeros. So 1 plus x of 1 is 1 into e power minus j pi by 4. We can write this as cos pi by 4 minus j sin pi by 4 plus 1 into e power minus j pi by 2 can be written as cos pi by 2 minus j sin pi by 2. Similarly, e power minus j 3 pi by 4 is cos 3 pi by 4 minus j sin 3 pi by 4. So, similarly, e power minus j pi can be written as cos pi minus j sin pi. E power minus j pi by j pi 5 pi by 4 can be written as cos pi by 4 minus j sin pi by 4 plus 0 plus 0. So by simply substituting these values, so cos pi by 4 is 0.707 minus j points. Like this, by simply substituting all these values in the above expression, we will get minus 0.707 minus j 1.707. That is the value of x of 1. Similarly, x of 2, k equal to x of 2 can be calculated like this. Here x of 2, yeah, n value is 2. Okay, k value is 2, n value is 2, k value is 2. So by simply substituting these values, we will get x of 0 plus x of 1 into e power minus j5 by 2 plus x of 2 into e power minus j5 plus x of 3 into e power minus j35 by 2 plus x of 4 into e power minus j35 plus x of 5 into e power minus j55 by 2 plus 0 plus 0. So in the same manner, e power minus j5 by 2 cos 5 by 2 minus j75 by 2 cos 5 minus j75 by 2 cos 35 by 2 minus j35 by 2 cos 25 minus j75 cos 55 by 2 minus j75. Okay, by simply substituting the values, we will get the value of x of 2 is 1 minus j 1 minus j. In the same manner, if you substitute the value of k equal to 3, k is 3 and n is 1 to 3 up to 7. So by substituting these values, we will get the x of 3 value is 0.707 plus j 2.293. Similarly, for k equal to 4, x of 4 is this one, that is 0. K equal to 5. For k equal to 5, x of 5 is 0.707 minus j 0.293. For k equal to 6, x of 6 is 1 plus j. For k equal to 7, x of 7 is 0.7 minus 0.707 plus j 1.707. I simply write all these values as a single set. That is x of k equal to 6. This is x of 0 value, x of 1, x of 2, x of 3, x of 4, x of 5, and x of 6 values. Okay, x of 6 and x of 7 values. So this is the 8-point DFT of the given sequence x of n equal to 1, 1, 1, 1, 1, 1, 1, 0, 0. Okay, so this is 8-point DFT. Similarly, you can find the inverse DFT of the sequence. Inverse DFT of the sequence. So, what is the sequence given? The sequence given is x of k equal to 5, 0, 1 minus j, 0, 1, 0, 1 plus j, 0. This is the sequence given. Having the length n equal to n equal to 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so n minus 1 is 8 minus 1, 7. Okay, so what is the formula for finding the inverse discrete Fourier transform? That is x of n equal to 1 by n at sigma k equal to 0 to n minus 1. X of k into e power plus j 2 pi n k by n, where n is varying from 0 to n minus 1. Okay, so here n is 8, so it is 1 by 8 into sigma k equal to 0 to n minus 1, that is 8 minus 1, 7 into x of k into e power j 2 pi n k by 8. That is 2, 4, 2, 8 gets cancelled by 4. So it is j pi n k by 4, where n equal to 0 to 7, right? So for n equal to 0, if n is 0, x of 0 is 1 by 8 into x of 0 into e power 0, k is 0, k is 0. Okay. First x is 0, like this, k is 0, k is 0 to 7, x of 1, x of 8. Server after here, so here n is 0, so that we will get 1 by 8 into 5 plus 0 plus 1 minus 8 plus 0 plus 1 plus 0 plus 1 plus 0 plus 0, so it is 1 by 8 into 8, it is 1. So 0 value will become 1. If n equal to 1, x of 1 equal to 1 by 8 into sigma k equal to 0 to 7, x of k into this one here, k value, n value is 1, here n value is 1, so it will become j by k by 4. Okay. So by simply substituting k values from 0 to 7 here. So x of 0 and e power 0 plus x of 1 and e power k pi into 1 by 4 plus x of 2 and e power k pi into 2 by 4. Similarly, x of 2 and e power 3 pi by 4 plus x of 4 and e power k 4 pi by 4 plus x of 4 and e power k 5 pi by 4 plus x of 6 into e power k 6 pi by 4 plus x of 7 and e power k 7 pi by 4. Okay. So it is e power k 5 by 4 is x of 0 into e power 3, that will become x of 1 value is x of 1 value, what is x of 1 value, that is 0, it will become 0. Next x of 2 value is 1 minus j, is 1 minus j into e power k 5 by 2 is cos pi by 2 plus j sin pi by 2 plus 0. Next, cos pi plus j sin pi. Okay, this is 1 by j into cos 3 pi by 2 plus j sin 3 pi by 2 plus x of family j. Okay, right. So by simply substituting these values in this expression, we will get the 1 by 8 into 5 plus 1 minus j into j plus 0 plus 1 minus of minus 1 plus 1 plus j into minus j. So that it will become 1 by 8 into 5 plus 1, that is 6 by 8, it is 0.75. For n equal to x of t is 1 by 8 into, in the same manner, sigma k equal to 0 to 7 x of k into e power j 2 by 2k by 8, 2k by 4. Okay. So by simply substituting these values, we will get x of 2 value is 0.5. Similarly, x of 3 value, that is also 0.25. X of 4 value, that is 1. X of 5 value, that is 0.75. X of 6 value, that is 0.5. And x of 7 value, that is 0.25. By simply writing these values as a set, x of n is equal to 1.75, 0.5, 0.25, 1.75, 0.5, and 0.25. This is nothing but the inverse discrete Fourier transform of the given sequence, that is x of n is x of k equal to 5, 0, 1, 0, 1, 0, 1 plus j 0. Okay. Next, we will see the relationship to the DFT to other transforms. How this DFT is related to other transforms. Okay. How this DFT, discrete Fourier transform, is related to other transforms. Okay. Okay. See. First of all, we will see the relationship to the Fourier transform. So the Fourier transform of e power k omega of the finite duration sequence is given as x of e power k omega equals sigma n equal to 0 to n minus 1 x of n at e power minus j omega n. That is equation number 1. Okay. Where x of e power k omega is a continuous function of omega. Continuous function of omega. Okay. The discrete Fourier transform of x of n is given by x of k is equal to sigma n equal to 0 to n minus 1 x of n e power minus j 2 pi n k by 2 pi n k by n. Okay, 2 pi n k by n. Where k equal to 0, 1, 2 up to n minus 1. 0, 1, 2, 3, 4 up to n minus 1. That is stated as equation number 2. Whereas Fourier series Fourier transform equation is stated as equation number 1. Okay, by comparing the equations 1 and 2, we find that the DFT of x of n is a sample version of the Fourier transform of the sequence and is given by x of k equal to x of e omega at omega equal to 2 pi k by n. 2 pi k by n. 2 pi k by n is omega. If 2 pi k by n is omega, then it is nothing but Fourier transform, discrete Fourier transform is also equal to just Fourier transform at omega equal to 2 pi into k by n, where k is 0, 1, 2 up to n minus 1. Up to n minus 1. Okay. N minus 1. So only thing is by comparing these two at omega equal to 2 pi into k by n, this Fourier transform is equal to our Fourier transform. Okay. Now compared to Z transforms, relationship to the Z transform. Let us consider the sequence x of n of finite duration n with Z transform, that is x of z equal to sigma n equal to 0 to or n equal to 0 to n minus 1 x of n into z power minus n. Okay. So, but x of n is equal to 1 by n sigma k equal to 0 to n minus 1 x of k e power k 2 pi n k by n. That is equation number 2. By comparing substituting equation in equation 1, we will get that x of z is equal to sigma n equal to 0 to n minus 1 1 by n into sigma k equal to 0 to n minus 1 x of k equal to 2 by n k by n z power minus n z power minus n by interchanging the summation 1 by n into sigma k equal to 0 to n minus 1 x of k into sigma n equal to 0 to n minus 1 into e power minus j 2 by n k by n into z power minus 1 whole power n. Okay. So it will become 1 by n sigma k equal to 0 to n minus 1 x of k into 1 by 1 minus alpha. It is z power, it is alpha power n. It will become 1 by 1 minus alpha. It is also in the form of 1 by 1 minus alpha. Okay. So that it will become 1 by n into 1 by n with z power minus n into sigma k equal to 0 to n minus 1 x of k by 1 minus e power minus j 2 by k n by n into z power minus 1. Okay. So this is a comparison of DFT with the Z transform. Next we will see the properties of DFT, discrete Fourier transform. So we discussed about the properties, but the proofs we didn't discuss. So now we will see the proofs of the properties. The first one is linearity property. The linearity property of DSP states DFT, discrete Fourier transform, states that the DFT of a linear weighted combination of two or more signals is equal to similar linear weighted combination of the DFT of the individual signals. Okay, so this is the statement of the linearity property. The linearity property of DSP states that the DFT of a linear weighted combination of two or more signals is equal to the similar linear weighted combination of the DFT of individual signals. Let DFT of x1 of n is x1 of k and DFT of x2 of n is x2 of k. Then by linearity property, DFT of a1 into x1 of n plus a2 into x2 of n is equal to a1 into x1 of k plus a2 into x2 of k, where a1 and a2 are constants. Okay, a1 and a2 are constants. Let us prove this. So by definition, the discrete Fourier transform x1 of k equal DFT of x1 of n. So by mathematical it is expressed as sigma n equal to 0 to n minus 1 x1 of n into e power minus j 2 pi k n by n. Similarly, in the same manner, x2 of k equal to DFT of x2 of n. That is sigma n equal to 0 to n minus 1 x2 of n into e power minus j 2 pi into k n by n. Okay, k n by n. So DFT of a1 into x1 of n plus a2 into x2 of n is equal to sigma n equal to 0 to n minus 1. Okay, a1 into x1 of n plus a2 into x2 of n into e power minus j 2 pi k n by n. Or we can multiply with this one. So sigma n equal to 0 to n minus 1 a1 into x1 into e power minus j 2 pi k n by n plus a2 into x2 of n into e power minus j 2 pi n k by n. Or we can write this as a1 into sigma n equal to 0 to n minus 1 x1 of n into e power minus j 2 pi n k by n plus a2 into sigma n equal to 0 to n minus 1 x2 of n into e power minus j 2 pi n k by n. Or this is x1 of k and this is x2 of k. Hence the result. So it is a1 into x1 of k plus a2 into x2 of k. So therefore DFT of a1 into x1 of n plus a2 into x2 of n is equal to a1 into x1 of k plus a2 into x2 of k. Okay, like this will prove the linearity property. Next one is periodicity property. Periodicity. If a sequence x of n is periodic with the periodicity of n samples, then n point DFT x of k is also periodic with a periodicity of n samples. If a sequence x of n is periodic with the periodicity of n samples, then n point is uh, n number of DFT, that is n point DFT, that is x of k. Okay, x of k is also periodic with a periodicity of n samples. Hence, if x of n and x of k are n point DFT pair, then x of n plus n is equal to x of n for all n, and x of a plus n is equal to x of k for all k. Okay. Now let us do this. Let us do this periodicity property. So by the definition of DFT, the k plus n quotient of x of k is given by k plus n quotient of x of k is given by x of k plus n is equal to sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n into k plus n by n, or we can write this as sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n into e power minus j 2 pi n into n by n. Okay. So sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n into e power minus j 2 pi n. Okay. So it is equal to sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n. For integer n, e power minus j 2 pi n equal to 1. So this value will become 1. So that it will become sigma n equal to 0 to n minus 1 x of n into e power minus j 2 pi n k by n. So it is nothing but x of k. So x of k plus n equal to x of k. This is the periodicity property. X of k plus 2 pi. X of n plus n is x of n, and x of k plus n is x of k for all values of k. So hence proved x of k. Okay. So next, circular time shift. Circular time shift. Third property, circular time shift. The circular time shift property of DFT says that if a discrete time signal is circularly shifted in time by m units, then its DFT is multiplied by e power minus j 2 pi km by n. Okay. So the statement of the circular time shift is defined like this. The circular time shift property of DFT says that if a discrete time signal is circularly shifted in time by m units, then its DFT is also multiplied by e power minus j 2 pi km by n. That is DFT of x of n equal to x of k. Then DFT of x of n minus m with n is equal to x of k into e power minus j 2 pi km by n. X of n minus m suffix n is equal to x of k into e power minus j 2 pi km by n. So let us prove this. So DFT of x of n minus m suffix n is equal to sigma k equal to 0 to n minus 1 x of n minus m into e power minus j 2 pi n k by n. Let p equal to n minus m. Then n will become p plus m, so that sigma p equal to 0 to n minus 1 x of p into e power minus j 2 pi k into n will become p plus m by n. Okay. So it is equal to sigma p equal to 0 to n minus 1 x of p into e power minus j 2 pi k p by n into e power 2 pi k n by n, right? So sigma p equal to 0 to n minus 1 x of p into e power minus j 2 pi into k p by n whole into e power minus j 2 pi k n by n. Okay, so that it will be this entire thing as x of k into e power minus j 2 pi k n by n. Okay, so this is x of k into e power minus j 2 pi into k n by n, hence proved. This is the circular time shift. Okay, so DFT of x of n is x of k, and DFT of x of n minus m suffix m will become x of k into e power minus j 2 pi k n by n. It will be proved like this. Okay. So today's class we discussed about the problems related to 8-point DFT and 8-point IDFT. Okay. Then do some properties of DFT. Then we'll compare this DFT with the other transforms like Fourier transform and jet transform, etc. Okay, Fourier transform and jet transform. Then we will discuss about the properties of DFT, linearity property, shifting property, okay, periodicity property, okay, then circular time shift property, okay. Remaining topics we will discuss in the next class. Okay, with this concluding the today's class. Thank you.